Got time from your busy schedule and joining us today. Good afternoon. Welcoming everyone to the second day of Solar Project Engineering Week 2021 Asia. I would like to thank our sponsor, Silver Partners Core Energy, for joining us today. Attendees, please note we would be having Solar Project Engineering Week ASEAN 2021 Awards in continuation with the virtual conference after we finish the panel discussions. So requesting all the attendees to stay tuned with us till the end of the award ceremony. With this, let's begin with our first presentation on engineering challenges in solar plus storage by Mr. Robert D. Groot, who is an energy storage specialist from Mott MacDonald. Over to you, sir. You'll have to unmute yourself.
Yes, am I unmuted now?
Perfect, sir. Can you please make it full screen?
Yes.
Thank you.
Okay. Thank you very much. Thank you for the introduction. I'm going to give a short presentation on engineering challenges in floating solar and energy storage. As I was already mentioned, my name is Robert de Groot. I'm an energy storage specialist and I work for Mott MacDonald and I'm based in Singapore. A very quick overview for those of you that are not familiar with Mott MacDonald. We are an engineering consultancy. We work in 135 countries, out of 170 permanent offices in over 50 of those countries. I have about 16,000 colleagues, and we have 150 years of heritage in engineering consulting. We are active in several sectors, and one of them is energy, and a subsector of energy is renewables. So I would like to give you some figures on what we do in renewables, specifically in this part of the world, so in the Asia Pacific region. We have a solar PV experience of over 30 gigawatts worldwide. For wind, both onshore and offshore, we have an experience of 90 gigawatts worldwide, of which 15 gigawatts in the Asia Pacific region, and including an offshore project under development of over 1 gigawatt. In Asia Pacific, we have 100 professionals in our renewables teams. And they are based in Japan, Thailand, Taiwan, Malaysia, and like me, in Singapore. And we support PV, wind, and battery energy storage projects throughout the Asia Pacific region. We have a unique PV plant simulation optimization capability, and we have a lot of experience in owner's engineering and site supervision for PV projects, including floating solar. And more than 50% of the global offshore wind parks to begin construction have been advised by Mott MacDonald at this point. And we also handled many first-of-a-kind solar PV projects in this part of the world, including several of the floating solar projects. So on to the content of the presentation. I would first want to pose a bit of a problem statement. While we move towards large-scale renewable baseload generation in Southeast Asia, there's a few things that we need to keep in mind. As you can see on the right, the population density in this part of the world is really quite high. Actually, to be more precise, the circle that contains half of the world population is even a little bit smaller. And it excludes most of Japan, which is a very populated country in itself. And that means there are land constraints near population centers. There's also high population growth, putting a further pressure on land use. Combined with that, there's a high growth of electricity consumption, partially because of the quickly growing economies in this part of the world. And last but not least, in many of the urban areas, there are air quality concerns. And above all, many governments have ambitions to reduce greenhouse gas emissions. So all these things combined they bring up an opportunity for floating solar and energy storage, and well, a couple reasons why. The combination of energy storage and floating PV gives it the ability to provide baseload power. This can be in combination with battery energy storage, but also a technology like pumped hydro, which is a common combination. So where the floating PV is installed on the lake of the hydro plant. It offers an opportunity for large-scale solar PV without the issues surrounding land availability. And that also makes it possible to have the floating solar plants closer to population centers, so closer to the cities where the energy is consumed. Another additional benefit is that often leads to the availability of supporting infrastructure, so things like access roads and the distribution and transmission grids are already largely there. So there's an opportunity for cost saving and optimization there. And well, finally, to address the air quality concerns and the emissions concerns, it's a source of clean energy, which is something we should all be aiming for. So when it comes to the floating solar, there are a couple of engineering challenges and considerations, some of which are valid for all solar plants, but some of them are unique to floating solar. And these things are things like wind loads, wave loads. Obviously, that one very specific to floating solar. The variation in water levels over time. Things like the anchoring design, it's pretty new to the solar PV community, I would say, to have to design an anchoring. And well, the increased humidity and increased saline environment that a floating solar plant has to operate in also plays a big part in your design and engineering considerations. I won't go through all the details in this slide, but I think on top of that, we need to be aware of the potential for natural hazards. Floating solar tends to be a bit more sensitive to natural hazards. There's also a photo in the corner, which is a floating solar plant which is damaged after a typhoon in Japan. Also, all the technology selection needs to be suitable for floating solar. And another very important point is safety, and especially procedures around maintenance and safe working are things that are not really very well standardized yet, and therefore is something that requires additional consideration. So when we talk about floating solar, a bit of an overview of the opportunities and the challenges, and then specifically for Southeast Asia, perhaps, or Asia Pacific region in general. There is an abundance of inland water surfaces. So as a result of that, it saves land space and it potentially reduces cost of a solar plant because you can reduce land cost. Whenever you put solar panels on water or above water, there's a cooling effect from the water, which potentially can lead to an output gain. Typically, there's less shading by the immediate surroundings. So that's an additional advantage and potentially a source of output gain. And when there's a combination with hydro plants, there is less evaporation from the water body that the panels are installed on, which is sort of a combined improvement of the solar and hydro plant combined. The challenges are a lack of track record at scale, although that's changing quickly. Many larger plants are coming online. There's a lack of supporting standards, as I already mentioned, especially when it comes to health and safety. Very important to spend extra attention in making sure working procedures, etc., are safe. There's the technical complexity in key design areas. There's a natural hazard risk, which is different from the natural hazard risk from on-land solar. So again, requires additional attention. And there is still a disadvantage in terms of cost. Well, one of the major items is the transportation of the floats. They're relatively bulky. Depending on where they need to end up, the transportation cost can add up quickly. So, what is then the synergy of floating solar with energy storage? First of all, solar and storage, we see a growing trend in the APAC region. It's often part of a hybrid power plant. Hybrid power plant can consist of many different components, but solar and storage are almost always part of it. When it comes to solar and storage, there are several applications such as ramp rate control requirements, which we see in parts of Japan. There are certain market incentives in the region that benefit storage projects, for example, the REC scheme in Korea. And we also see a growing interest in even gigawatt scale baseload plants, so plants that really can provide power for 24/7 or for 18 hours a day, and at very large scales. And as said, if you combine that with the pressures in land use, then energy storage and floating solar can really make a good marriage in making such large scale projects happen. There are, however, also on the battery side, there are still technical challenges. First is the technology selection, and then the maturity of certain technologies. For lithium ion, that's less of a concern, but for other technologies, there's definitely still room for growth and for further maturation of the technology. Very important aspect is the sizing of the energy storage, the siting, and also the degradation estimation, to make sure the battery performs well throughout the lifetime of the project. And also a review and in parts standardization of O&M procedures, and also warranties, not only equipment warranties, but also performance warranties of battery storage. And in general, just the standardization of the technology itself is something that still, well, there's room for growth and all of it becoming more mature. And last but not least, there's the safety of energy storage systems. This has already improved quite a bit in recent years, although there are still problems are being reported. And a lot of these problems can actually be solved in the earlier stages of the project development. So during the design stages and the early reviewing, a lot of those problems can be solved. So what opportunity, in a bit of a conclusion, is there then for floating solar and energy storage? First of all, if floating solar is co-located with a hydro plant or pumped storage plant, there are reduced evaporation rates. There's a possibility to smooth the power output by controlling the solar and the hydro together. And very often the infrastructure is already in place. If the hydro plant is already there, there is going to be a good interconnection capacity. So there are some optimization opportunities there. And if floating solar is combined with energy storage, battery energy storage to be precise, an advantage is that there are potentially no seasonality gaps that might happen when you co-locate floating solar with a hydro plant. It is very much so less dependent on specific geographic features, so you're more flexible in where to locate it, and that also means you have an increased flexibility to locate it near the population centers that were mentioned earlier. So all in all, besides the engineering challenges, I think there are good opportunities for floating solar in this region. And we even expect that the Asia Pacific region will be dominant in floating solar in terms of installed capacity worldwide in the years to come. So that was my presentation. Thank you very much.
Thank you very much, sir, for the valuable insights. Attendees, I would be launching few polls for you before we proceed ahead with the panel discussion. So here comes your first poll. Do you foresee storage coupled with solar a trend going forward in the Asian region? Am I closing the poll now?
Yes.
So that's an
So
optimistic number. 68% of attendees agree with it. Thank you, attendees. Here comes your second poll. According to you, a combination of renewable energy sources will lead to cheaper and secure energy systems. I'm closing the poll now. So we have around 45 plus 45, around 80, 85 people agreeing to the fact that yes, it's very likely. Thank you all the attendees. With this, we will proceed ahead with our panel discussion. The topic of panel discussion is going to be hybridization, engineering aspects of solar plus storage. Session experts who have joined us today are Mr. Stephen Dutta, who is the CTO from Sembure Solar, Mr. Robert D. Groot, who is an energy storage specialist from Mott MacDonald, Mr. Vayu Parbovo, who is a business development manager from TML Energy, and Mr. Simon Wong, who is a general manager from Plus Solar. I would like to hand over the session to Mr. Simon to take the discussions forward with other speakers. Thank you.
Thank you, Sangeeta. Good evening, ladies and gentlemen. I am Simon from Plus Solar Malaysia. We are one of the country-leading solar EPC companies in Malaysia. So today, together with us, we have a few panel speakers who are experts in their respective field. So later on, we are going to talk about in details on some of the issues regarding hybrid and storage systems in terms of the implementation, the challenges, and some key considerations. So hopefully our panel speakers will be able to share with us some of the insights that they have gathered along the way of their experience. So before we proceed further with the question, let us welcome our panel speakers to give a brief introduction about their backgrounds and their area of specialization. So let's start with Mr. Robert. If you don't mind, you can just give us a brief introduction about yourself, not your company, yourself.
yeah, yes, yeah. So I'm Robert de Groot. I'm based in Singapore since about 5 years now. I work with Mott MacDonald as an energy storage specialist, and by training, I am an electrical engineer, and I'm originally from the Netherlands.
Thank you. Thanks, Robert. All right. Next up, we have Mr. Stefan.
Good afternoon, everybody. My name is Stefan Dudel. I'm the CTO of Sembure Solar. I'm an electrical engineer and 14 years in renewable energy, now based in Bangkok. And we are developing commercial industrial rooftop solutions.
All right. Thanks, Mr. Stefan. And last but not least, we have Mr. Vayu.
Hello, good afternoon, everyone. My name is Wahyu Parbowo. I am an electrical engineer. I work in TML Energy, which is an EPC for solar energy in Indonesia, and I've worked here for the last 7 years.
All right, thanks, Vayu. Okay, so without further ado, let's jump into the first questions that I wish to direct this question to Mr. Robert. So just now in your presentation, you share about some insights on how the storage system can help to address the baseload issue. So aside than the baseload issue, what are some other common applications that people or the developer may consider before they decide on implementing a storage system? Mr. Robert, you may need to unmute yourself.
Yeah, it's an interesting question. There are actually many different applications for energy storage. So I could go on about this for very long, but I'll try to keep it focused. So, well, one of the application obviously is to provide power output smoothing of your renewable energy source, right? So both wind and solar are variable, are intermittent, and you can smooth the output of such a plant by adding energy storage, and that's basically what you do if you want to provide base load. But other common applications that I see in this part of the world, first of all, is basically shifting of energy. So what you see under the REC scheme in Korea is that basically better tariffs are provided at nighttime for solar energy. So it makes sense to store a part or all of that energy during the day and then discharge it in the evening, in the early evening, and during the night, and get a better tariff paid for the same amount of energy, basically. Another one is more in the realm of ancillary services, grid stability, frequency support, voltage support. So, for example, in Hokkaido in Japan, there's now even a requirement that for variable renewable energy sources, so both wind and solar, the ramp rate of the output does not vary more than 1% per minute of the installed capacity. Which means both wind and solar vary by nature very faster than that. So you need a battery storage to sort of dampen that variability and reduce the ramp rates, as they are called, to levels that are acceptable within that requirement. So that's a very interesting application, and the idea behind this is to stabilize the output and with that stabilize the grid. So by having less variability in your generation, your grid will have less problems sort of balancing supply and demand. And especially if you go to higher penetration rates of renewable energy, this becomes more and more important. So in my opinion, this is something that eventually is going to happen in all the grids. Hokkaido in Japan is just an early example of it, but also many of the countries in Southeast Asia will eventually end up having a certain degree of battery storage in the grid, fulfilling a similar role.
All right, thanks for the insightful details, Mr. Robert. So for Mr. Stephen, I believe for more than 10 years of your experience in this industry, can you share with us some of your experience dealing with hybrid energy systems implementation? And usually, what are the considerations that your organization will take before you decide what kind of energy sources to be included in the hybrid system?
Sure, thanks, Simon. I mean, although I'm more than 10 years in the industry, of course, the battery experience is not that long. This is still a very young field and a very new aspect for us and many of our clients. We recently had a client about a year ago came to us and said, we want to become 100% depending on solar energy only. We want to be 100% renewable, and we want to use storage really to achieve that. And unfortunately, that client couldn't tell us much about their load. In fact, they were just about to build their factory and didn't have any load data. And this is something that you really want to know when you design a battery system. You want to know what's the total consumption. You want to know what's the maximum, minimum power. You want to know how much they're using in the day and the night, how much on the weekend, how much is seasonal. And all this data was basically not available. So the step that we took actually was to grow with the client and to develop a kind of phase plan to go in with a very conservative assumption, and then to have a period where we measure the load and grow with them. So what we did basically is we designed the system based on the nameplate power of their production equipment and their estimated operation times. And we went in with a very small system, very small solar system, very small battery system, and we're able in the first step then to reach about 70% of their load by renewable energy. And we're now in the phase 2, where we're trying to reach a target of 90%. And this is possible after the plant has been operating now for half a year, where we're able to collect a lot of data. Now we understand the operational pattern, we understand the load data. So with that, we're now much better able to make simulations for the next expansions.
I see. Thanks. I think Mr. Stefan, you pointed out a very important consideration whereby for some of the sites, we do not have existing load data. So we can only work on based on some certain assumptions. Yeah. So back to Mr. Robert and Mr. Stefan, aside than waiting for a period of probably 6 months or more to collect the site data, there are also certain sites where their load demand will gradually pick up over a period of time. So what are some of the advice that you can share with us on how can we design our hybrid storage system so that it can be scalable in the future to meet the load demand?
I can take that one. Well, it's as Stefan already mentioned. It's well, maybe one of the most important inputs to the sizing of the plant, right? And the sizing of the individual components. So on the one hand, you can, if you don't have the data, you can try to model what your load is going to look like. In some cases, that is possible. Personally, I've been involved in a couple of remote electrification projects where we were going to electrify an area that currently didn't have any electricity. So you have to basically guess how much electricity people are going to use. And that was largely residential. It was a relatively poor area, but still you need to get an idea. So the way we did it was literally through interviews, ask people what are they thinking of using the electricity for? What do they intend to buy in terms of equipment? Like, are they going to buy a fridge or a TV or etc.? And through that, well, there's a possibility to try to guess what the load is going to look like. So that's one part of the equation. But on the other hand, once you start to electrify such an area, well, that's very specific for off-grid electrification. The local economy tends to boom. And as economies grow, the energy consumption grows. So you're looking at growth rates of easily 10% per year, which is far above the averages of most countries for such an area. So if you have that flexibility, you should always plan for future expansion. So if you can already acquire additional land, or make sure you have the option of acquiring additional land later on to expand your solar plant, to install larger batteries or additional batteries, that would make a lot of sense. I think the advantage of renewable energy technology in general is that it's pretty modular, right? You can easily add 500 kilowatts or a megawatt of solar to an existing system, and in a way the same goes for the batteries, right? So although the specifications change over time, I mean, panels tend to get more efficient, batteries tend to be more energy dense. It is usually no problem to operate them side by side. So I guess a lot of it comes down to proper planning, basically.
Right. Thanks, Robert. Yeah. So I think proper planning is really an important factor, especially when it comes to hybrid and storage for a community, for behind the meter, or even for microgrid applications. So we have heard some perspective from the consultant side, from the developer side. I would be very much interested for us to hear the perspective from the perspective of an EPC. So for Mr. Vayu, in designing a hybrid storage system, is that the similar process that you go through also in coming up with the proper sizing? Maybe you can brief us through, from your experience, normally what are the usual process flow when it comes to design and build of a hybrid storage system?
Yeah, thank you, Mr. Simon. So yeah, we are an EPC company, TML Energy, that work in Indonesia. So a lot of our hybrid project usually targeting a small area or remote area across the country. And for the designing process, of course, we also cooperate with the developer to design a microgrid system or hybrid system with them. So the first issue or the first thing that we ask is certainly the load data, if that's available. But most of the time it is not, as Mr. Stephen and Robert has mentioned. That will be difficult to collect load data from site. And usually what we do is to model it using what we have. We already installed similar system across Indonesia, and we use the load data that those sites are using, and we model that to the site that we are developing. Then after that, of course, we need to know if it's already has an existing power source, maybe another power source other than solar energy, because we are focusing on solar energy. So maybe a diesel generator is already there and they want to use it, then we will try to acquire the data of the diesel power plant as well. But that's actually a bit difficult as well. Then after that, the geotechnical data and other stuff, then we will design it and propose it to the developer. At the sizing stage, we will also calculate the existing cost of generation, of course, from the existing system, or we will adjust that. We will size the system depend on how much renewable they want to use, or something like that. Yeah, that's if we join from the development phase. But other project that we have, the largest capacity for hybrid system that we have, actually a 3 megawatt peak hybrid system with 2 megawatt hour battery. The site owner, this is a coal mining company, they already decide the capacity. They have a consultant that they discuss with, and we do the detail engineering design. So with the capacity that they gave us, we do the detail engineering design for the construction drawings and how to integrate the hybrid system. The PV and battery system to their existing power plant. Those are the kind of project that we do, Mr. Sam.
Okay, thanks, Vayu. With there are in the market, there are so many different types of battery technologies. So, what are some of the consideration factors that you consider before deciding on what type of battery technologies to be proposed to the customers or to the site? So, this question is open to all three guest speakers to share with us. Yeah.
Maybe I can go first.
Sure.
For the battery type or the battery technology that we choose, usually will highly depend on the system that the operating scheme that they want to achieve. As Mr. Robert has mentioned, there are a lot of storage application, and we will see what kind of operation that they want with this storage, ancillary or storage. Shifting the energy will have different battery system, but generally I think currently lithium ion is on the top of the list. But yeah, we also use different types of batteries, such as lead acid or zinc air batteries.
Yeah, I think to add on to that, lithium ion is indeed the dominant technology at the moment, and even within lithium ion, you have a couple of choices in terms of the exact chemistry, and usually you're looking at a trade-off between the C rate that you can achieve, so the ratio between capacity and power, energy density, safety is perhaps a factor. Some of the chemistries are more stable at higher temperatures, and lifetime. So based on the project, you need to pick the chemistry that most closely matches your requirement. But I would say typically NMC and LFP lithium-ion batteries are by far the dominant technology at this point.
Yeah, I think I can confirm also in our area, the commercial industrial sector, the lithium-ion phosphate, they are the most popular ones. Also thinking that the size of our battery hardly exceeds a megawatt hour, and then that's an area where those batteries dominate.
I see. Okay. When it comes to megawatt hour scales of battery, there is another type of batteries, like we call it the flow type batteries. Have you come across any experience dealing with flow type batteries? And if yes, then probably you can share with us some of the experience that you face, advantages and disadvantages of having this type of batteries in the project.
I personally have not yet worked on a project where flow batteries are deployed commercially. There are a couple of examples globally in this part of the world. I think there are also a couple of pilot projects. Even there's one in Singapore, which is probably operating right now. It's around this time. But it's still very small. But just I think in general, one of the major advantages of flow batteries is that you have a complete decoupling between energy storage capacity and power capacity. You can design it freely. So if you need very long duration batteries, for example, you probably have to go for flow batteries. You can't really, at least not in an economical way, fix that with lithium-ion batteries. So that would be one possible application. And the other one is that you can, well, basically by replacing the chemicals in the battery, you can have almost an infinite lifetime of the battery system. So again, if you need very long project durations and you don't really want to take out a battery and put a completely new one in at year 10 or year 15, that could be an advantage as well. I think the downside so far is mainly the cost and the bankability.
I see.
The track record is simply too small, so many lenders are not very keen on financing projects with flow batteries in them.
All right, thanks. So just now, Mr. Robert, you pointed out a factor, which is the safety factors, which to seek inputs from all speakers over here. When it comes to the deployment of a project, is there any standards or that you comply with in order to ensure the quality and the safety as well as the reliability of the whole system are not being compromised? If there isn't any standards within the region of operation, what do you do to make sure that these parameters are being upheld?
Shall I take that one?
Yeah, sure. It's actually open for all. Yeah.
Okay. Well, it's one of the weaknesses of the subsector, I would say, of energy storage. Still, is that standardization is relatively weak, especially the enforcement of standardization. I think in most countries, even with developed energy storage markets, there is not much that is obligatory in terms of standardization and safety standards. Many jurisdictions are still relying on the developers to just to make sure that the battery system is safe. Having said that, there are a couple of standards, IEEE standards, UL standards for the different components of a typical battery system. So for the battery cells, typically for the PCS, for the inverter system. If you really take it a bit broader, you could even look into standards for the communication, etc. They're the general electrical standards that any electrical equipment should comply to begin with anyway. But that is a bit of a sort of a mix of separate standards that apply to each component. When it comes to the standardization of a whole battery system, it is still relatively limited. There is the off the top of my head, UL9540A, which looks into avoidance of thermal runaway in a battery system, and looks more in a more holistic way at the system as a whole, because there are several components in a battery system that play a part in avoiding thermal runaway. But I wouldn't say that it's sort of there's a watertight set of standards that really cover all aspects of battery storage at this point. So to come back to the safety point, I think it's important to look at the individual components, as I said, and apply those few very specific standards. And on top of that is just proper engineering practices, and a bit of common sense, perhaps even. Also, one aspect, for example, that's really important is to make sure that the local fire department is trained properly in dealing with a battery fire, for example. A lot of people are probably familiar with the accident that happened in Arizona, I think 1-2 years ago, where a couple of people from the fire department got injured and ended up in the hospital, and that could have been avoided if they would have been trained on how to extinguish such a fire. So that's another aspect that you can't really capture in a standard, but is I think is really important.
Yeah, I do agree with you, because even in Malaysia, although our demand for energy storage is not that high, but when it comes to the usual commercial solar implementation, the fire safety awareness has become higher and higher. That's also thanks to the news media that's shared by global news agencies about those fire risks that is caused by the solar. Yeah. So I think the fire safety is something that we especially in Southeast Asia country, we learn along the way, and then we slowly adopt a better and more stringent standards to ensure the safety is being kept at a good side. So Mr. Vayu, based
Yes,
on
sir.
your experience, what are some of the main challenges that is impeding the implementation of a hybrid storage project?
Yeah. Yeah, main challenges on implementing the hybrid project. Well, first of all, the data acquisition. As we have discussed before, acquiring accurate data, accurate load or demand will be very important to designing the project. So that's one part. And then whether it is the next one is the existing system. Well, if it's a greenfield project, if we install a new power plant, that's sometimes easier than if we have to integrate with the existing system. For example, we have integrate solar power plant with battery to an existing diesel generator and coal-fired power plant, and they only use the diesel generator manually. So yeah, the integration, the change for their operators to that do their day-by-day activity manually, then change to a more automatic system, we will feel like that will be easier, but in practice that's quite a challenge as well. And then some of the project owner is not, is still indecisive on what they want to achieve with this hybrid system. There are a lot of application for storage system or hybrid system, but they still confused about what to achieve. So let's say on the design phase, they want to they only want to stabilize the PV generation or renewable generation, the intermittency. But then along the way during construction, they want to add more features, but that should be decided on the design phase. That's quite a challenge as well. And maybe cost. Yeah, cost is still it's going down, but it's still quite a challenge here. We can compete with diesel generator, but with other generation, I think it's still hard to match them.
Okay, thanks.
Yeah.
All right. Actually, I think in Malaysia we also face similar challenges, whereby when we receive a lot of inquiry from prospects asking us to propose them some solution on solar plus storage because they would like to go green. But the main challenge always comes to dollar and cents. When they look at the cost, the capex and the opex, then they back off. Yeah. So in order to overcome these commercial feasibility issues, what are some of the suggestions that you can provide to us or to the government in Southeast Asian context, especially? Yeah, in order to promote more and more adoption of hybrid solar plus storage or hybrid plus storage systems. Maybe Mr. Stefan, you can go first.
Yeah, in my area, I'm not able to rely on governments. We're acting behind the meter and deal directly with our clients. One way for us to control cost is really to build in the flexibility and grow the system with the needs of your client. In our case, for example, that client just started a factory from scratch and had plans to increase the production output and the production equipment over the years. So we will simply grow with them, and we have to build that flexibility of growth into the system also. We do that, for example, by using an AC coupled system, which makes it much easier to grow the solar and the battery independently from each other.
Thanks. What about Mr. Robert? What's your view?
Yes. Well, when it comes to behind the meter, I completely agree that you can't really rely much on the government. And an approach suggested by Stefan makes a lot of sense. If I look at so-called before the meter, I mean, solar is taking off almost everywhere, I would like to say. So I think the right incentives and regulations are in place in most places around Asia. But for batteries, it's a very different story. And I would say development of batteries or energy storage in general entirely relies on the right incentives and the right regulations to be in place. A battery by itself doesn't generate anything. Best case scenario, it only consumes some energy in its losses. So in order to really have value from a battery system, I mean, there are definitely ways to create value with a battery system. The owner or the operator of that system need to be incentivized in the correct way. So if a battery is installed to help stability in the grid, then somebody who's owning and operating that battery system should be compensated for providing that service to the grid. And that's exactly where things start to get complicated, because in many countries, such rules and regulations are simply not yet in place, or the market doesn't exist, or so it is very important for governments in general to provide the right regulations and make batteries a part of the road to high penetration levels of solar and wind in grids.
All right, thanks, Robert. Were you maybe sharing from the perspective of your country and how your government promote, encourage this? What are the things that you see that is actually really encouraging the growth of this, or what are the things that you think it is missing in the link in order to make this a success?
Yeah. Oh, sorry. Go ahead, please.
No, go ahead.
Yeah, as Mr. Robert mentioned, the correct way to incentivize will be really great help. Yeah. Here in Indonesia, we still need to compete with the local generation costs from the grid provider the utility provider. So yeah, it's a challenge. And well, there is a program that to decrease the diesel generation, to replace it with solar and storage, and I'm seeing that grow, and a lot of developer come in to propose that. So that's the good news here. But yeah, the good incentive is, I think, still not there, because the new system still need to compete with the existing local generation cost.
Right. Thanks. So me personally, coming from Malaysia, based on my experience in Malaysia so far, I think in terms of behind the meter application, yes, incentive is really a kickstarter to me. Looking at the high capex, and to be honest, our electricity tariff is still the lowest among the region. Yeah. So without a proper incentive in place, then the no. Even with incentive, like currently we have this kind of investment tax allowance that is allowed for people that is investing into battery storage and solar. Looking at the payback period is still in a rather long timeline, where for most of the business owners, this is something that become a roadblock for them to invest in it. So I think how to bring down the technology cost and how to create a more attractive incentive is also something that is important to encourage more growth on the behind the meter application. On the other hand, also in Malaysia, what I personally feel is that the mentality and the determination from the government is also very crucial to really, if they want to push this, then they have to be very aggressive, and they have to act very boldly in coming out with plans and providing proper infrastructure to encourage the people to adopt into this. So I think Singapore, they have begun to increase the attention to energy storage, and they even roll out an energy storage program where they secure the funding, and then they get people to involve in a test bed program. So a successful top-down approach is also something that is important to ensure a success on this. Yeah. So this is my personal experience coming from Malaysia. So I think we almost come to an end in this sharing. Fellow audience, if you have any questions, please feel free to post your question in the Q&A column, and then we will direct the questions to the fellow panelists over here to provide their insights.
So we have received 2 questions in the Q&A box. Would be glad if you could take up those questions.
All right. So there is currently 2 questions on my list. So the first question, I believe this is directed to Mr. Robert. Any standard available for floating projects?
Well, there again, a bit similar to energy storage as we discussed just now. There are standards that apply to parts of a floating solar plant, but especially the floating aspect, or everything that's new to floating compared to how should I say, land-based solar. There is not much standardization in place yet. So that's also one of the engineering challenges for floating solar. So if I directly have to answer this question, not yet.
Okay, thanks. And the second questions that I have in the list is any rule of thumb when it comes to designing the integration of PV and storage. So I think one of the heavily discussed factor that we have to consider is regarding load profile, the load profile of the site. Yeah, so this is a very important factor that we have to have. So besides then the load profile, availability, is there any other rule of thumb that you normally consider when it comes to the design? So I think Vayu and Stefan, you can take this question.
Yeah, if I may start, I mean, the load is one thing, but the devil is very often in the detail. And one thing we learned, for example, very late was the topic of energy management system. So once you integrate a battery with your solar system, you need a controller that somehow manages how the two work together and also work together with the load that you have. And one thing we found out, for example, here in Thailand, we have a requirement from the utilities that we're not allowed to export any power to the grid. We even have to take measures not to do that. So we have to control the solar inverter and tell them to reduce the output whenever we're coming into an export situation. Now, since we're using the battery for shifting load or for actually taking excess power and shifting that power to times of low solar production, the battery is doing exactly the same. It's looking at the load side. When we're reaching zero export, it will, when we are reaching zero load, it will start charging. So now I have two controllers conflicting with each other. And I need an umbrella monitor, the energy manager, that controls all of that. And the battery, for example, that we bought was not able to do that. So that took considerable time to design and to engineer that later and to find workarounds. So, I mean, like Vayu also said, data is very important. Energy management is important. There are many other aspects than just simply the capacity and the power of a battery.
Thanks, Stefan. Vayu, you are.
Yeah.
Yeah.
Yeah. It's a difficult one for me because maybe as we have discussed heavily here, a lot of storage applications. So what do you want with this storage will impact greatly on the capacity that we will design. So yeah, it's come back to the original goal of the application of the storage, I think.
Thanks, Vayu. Yeah, if I may add on to the answers from the fellow speakers, yes, number one, load profile. Number two is the type of application that we want to use with battery storage. Whether you want to use it for load shifting, whether you want to use it for peak demand shaving, or a total replacement of existing genset. All these factors will actually affect how you design your storage capacity. Then the question is about PV plus storage. So I would say the other part of it is mainly on the PV system sizing, whether you have sufficient area for you to size up the PV capacity that you needed for your storage to be able to supply to your demand. So if you have them, that's good. If you don't have them, you may have to consider hybrid with whether conventional source or the diesel genset in order to meet up your application purpose. And finally, along the way, what I learned is that when it comes to decentralization, especially these hybrid sources and storage, software actually plays a very, very important role here, because when we have so many different sources and storage that is integrated together and to manage the load demand, the balance between supply and demand, the software become the brain of the entire system. So having a very holistic and a very, very up-to-date software, the controller systems, is very crucial for you to be able to ensure that you are able to balance between your supply capacity as well as your demand requirement. Yeah, so I think software is something that we have to start to embrace. It is no longer like the olden days where we only focus on hardware, then software is just like a bonus add-on. So today, when we talk about storage, software become one of the very, very key success factor. Yeah. Okay, so I think I still see one last questions in the chat. All right, for grid scale PV plant, should we consider an AC coupled battery energy storage system or DC coupled battery energy storage systems? So maybe Mr. Robert, you would like to take this?
Yeah, it's difficult to give a single answer to that question. Again, there's a lot of details that go into it. Roughly, I mean, DC coupled, you have the advantage of potentially less losses from solar to storage. Plus, you can over dimension your solar relative to the AC capacity a bit more than with an AC coupled system. So there's some room for optimization. On the other hand, at least right now, AC coupled systems are more common. They have generally a larger track record, and they have their own technical benefits as well. So again, this often comes down to the exact application and the how should I say, it boils down to a lot of detail that you need to look into. So it's very hard to give a A or B kind of answer to a question like this.
Okay, thanks, Robert. All right, so with that, we will end today's discussion session. Thank you very much to Mr. Robert, Mr. Stefan, and Mr. Vayu, and fellow audience for your time and effort to attend this session. So I will pass the floor back to Sangeeta. Thank you.
Thank you so much, all the key panelists, for your valuable insights. Simon sir, thank you so much for moderating today's session. Attendees, please stay tuned with us. So we are going to begin with Solar Project Engineering Week ASEAN 2021 Awards just now. So I would like to hand over the screen to Ms. Geeta to take the award ceremony forward. Thank you very much.
Thank you so much, Sangeeta. Thanks a lot. Thank you all the panelists. A very, very good evening, ladies and gentlemen, and welcome to Solar Project Engineering Week 2021 Award Ceremony. So the award ceremony is a platform that recognizes the best performers and achievers who have promoted and advanced the use of solar energy across the ASEAN region. I'm your host, Geeta Thakkar. So let's start with our first award category. Can I have the slide, please?
Geeta, just a minute.
Sure. So, ladies and gentlemen, the first category is Most Preferred Solar Module of the Year. So let us know something about the company, the winning company, okay? Well, the company needs no introduction at all. It is a Tier 1 solar module manufacturer. Its leading multi-bus bar technology, the Vertex modules, comes with several innovative design features, allowing high power output of more than 550 watts, increasing the efficiency to 21.0%. Any guesses? And the winner is? And the winner is Trina Solar Company Limited. I would like to welcome Mr. Anil Puluru, Senior Manager, Trina Solar, to kindly say a few words. The stage is all yours. Mr. Anil, can I have your video and audio, please?
Yes, Geeta, can you hear me?
Yeah, we can hear you, but would like to see you too.
I think I am on video now. You're not able to see my video?
No, I'm not able to see it.
I must be visible now.
Actually, not able to see you, Mr. Anil.
I mean, my camera is on. I'm online, I think.
Okay, we'll just try and figure out. Can our team please figure out what the issue is?
They're perfectly fine from my side. I'm online.
Can you try switching it on again?
Yes. Can you see me now?
Actually, we're not able to see you, sir, but I think we can have your speech. With the team just figuring it out what exactly the issue is.
No problem. No problem. Thank you so much, Geeta. And we are honored to have this award. Thank you so much for first view. actually, this is the Vertex series is our special product launched last year globally. It was accepted very well, and we have bring in a lot of differentiation about this product, which is going to benefit the solar industry a lot. There are many projects that we have been currently doing with the Vertex series. This is a path-breaking product for the industry right now, and we strongly believe Vertex series is going to be in the market, and it is going to stay in the top position for next 5 to 10 years coming in. So because of its own advantages and the differentiation that is bringing in for the developers, for the EPC, and for the system integrators. Yeah, thank you, Geeta. Hello.
Thank you so much, Mr. Anil, for the lovely speech, and on congratulations on the great win. So moving on to our next category for the Solar Project Engineering Week Awards. Can we have the next category, please? So the next category is Solar Project Engineering Consultant of the Year. Now let's know something about this company. Well, the winning company is Asia's largest and purely solar-focused consulting company, and is now one of the leading reputed solar engineering consultancy in the world. With a massive 33 gigawatt consulting experience, the company is proud to have helped the government and organizations to achieve their renewable energy goals across 5 continents and 40 plus countries. Now that's an amazing work done by this company. So let us know who the winner is. And the award goes to and the award goes to Skar Energy India Private Limited. Can we have Mr. Sunil Kumar, Senior Marketing Executive, Skar Energy, on stage, please? Mr. Sunil?
Hi, Geeta. Thank you. Can you hear me?
Yes.
Thank you so much. In the first place, I would like to thank First View and Solar Quarter for organizing this engaging and insightful 2-day virtual conference. In fact, I attended the sessions on both the days and appreciate all the speakers for their valuable contribution. It was truly insightful. We would like to thank Solar Quarter for recognizing the sincere work of Skar Energy. Our primary mission has always been to promote and advance the use of solar energy, not just across the Asian region, but also across the world. For almost 2 decades now, we have been helping governments, organizations, and companies to realize their renewable energy dreams. And we continue to look forward to help more companies in the Asian region with our consulting expertise of 33 gigawatt and move towards a very sustainable future. Thank you once again, and thank you all for all the speakers today. Over to you, Geeta.
Yeah, thank you. Thank you so much, Mr. Sunil. Now, that is a very well-deserved victory for Skar. So I have a small question for you. So after so much of hard work the Skar Energy has put in to achieve this great victory, where is the party tonight? I'm sure there's going to be a lot of party tonight for the team, putting in so much of hard work, and also just let us know the secret place.
Absolutely. The party is going to be virtual.
Okay. We all are living in a virtual world today, right? That's right.
A year has passed by, and the world has changed, the dynamics have changed. Okay. And so should the party dynamics should change as well.
All right. So thank you so much, Mr. Sunil, and congratulations on the great win to you.
Thank you, Geeta.
Thank you.
Skar Energy as well.
All right. So moving on to our next category. Can we have a next category, please? So next category is Most Innovative Technology of the Year module. Well, the winning company is a leading module manufacturer which has launched its Vortex series modules in Feb 2020, which has low voltage, high string power design to advanced technology solutions. The optimized module design of the Vortex 600 watts and 550 watt series applying 210 mm cell is becoming the new benchmark. So by now you all might have guessed who the winner is. And the award goes to Trina Solar Company Limited. Now, can I have Mr. Anil Puluru, please?
Yes, Geeta, this time, can you see me at least this time?
I'm sorry,
No?
Mr. Anil, still an issue with the video there.
I think something wrong with some technology issue. Okay, fine. See, once again, thank you so much for choosing our Vertex product as most innovative technology. Yes, it is true innovative technology because the product differentiation that it brings to any EPC or any developer is really a lot of value. Like you presently mentioned the savings that the EPCs would see and the BOS and the flexibility that this product is going to provide on the engineering point of view. And it is as if like a normal product with 210 mm cells. The power pins are really high, and with the combination of your trackers and the bifacial panel, you're going to have very attractive LCOEs, and we strongly see this product is going to have a lot of market share in coming years. And I'm happy to share that we have already achieved our the BIS certificate for this product for India. So we hope to see a lot of installations with this particular Vertex series modules in India in coming quarters in future. Yeah, thank you. And it's really innovative technology that we had proposed to the market now.
Okay, thank you. Thank you so much, Mr. Anil. Now, I'll just request you to rejoin from your phone if you'd like to do that, so that if there's an issue with the laptop video, we can have it from the phone.
Sure, I will.
All right. Yeah, thank you. But you're not leaving right now. So,
Yep.
I have a question for you too. So I just want to understand, like, they're twice win in a row. It's a great achievement, and getting this award and this recognition in this module category is a great achievement in itself.
Yes,
so
yes.
what is that one oomph factor that makes Trina stand out to win these categories?
See, Trina, historically, we have been here in India market for last 10 years, and we go with the market, and it's our core values itself says it's a kind of customer-centric products that we develop, and we always go with win-win situation. We work with our clients very closely, so otherwise we won't be managing our leadership position for last 10 years in India. And this is what we feel the major differentiation as a company. And thanks to our senior management, day one onwards, they have very special focus on the market, and whatever happens globally, our shipments to India are on always consistently. We are shipping to India, and our focus remains same, whatever happens locally or internationally. So that's where the major differentiation that as a company we are bringing in to this market.
All right, that's really great to know. Thank you so much, Mr. Anil and Mr. Sunil, and congratulations on the great win to both the companies and the great achievements by the company and the team. Thank you so much.
Thank you.
Okay, ladies and gentlemen, every year Solar Quarter recognizes and celebrates the great work done by some of the pioneers in solar industry in the form of Grandmaster Awards. It gives us immense pleasure to acknowledge the achievements of such leaders who have contributed outstandingly towards the development of solar industry in the ASEAN region. So presenting you with the winners of these Grandmaster Awards. Our first award goes to Ms. Fung Yan Yen, sorry if I pronounced it wrong, the CEO of Tona Sintegra Solar. Can I have ma'am on the stage, please?
Yes, I am unmute and thank you. So you want me to say the...
Yeah, if you could just, it's a Grandmaster Award for your outstanding, contribution to the solar industry in ASEAN region. So kindly let us know, how, what great achievements have the company done, and how is the journey that has led to, this kind of Grandmaster Awards.
Yeah, thank you very much. I would like to firstly thank Solar Quarter and organizer to firstly organize very helpful and insightful series of workshops during the, especially during last year to 2020, and also to recognize Tona Sintegra Solar in this Grandmaster Award. I would say that Vietnam has been a remarkable case study in the entire world in terms of speedy growth of the installed capacities of PV solar. Now, the country already achieved more than 16 gigawatt. And in 2020, particularly, then more than 10 gigawatt were installed. And especially for rooftop, it's reached 9.6. And among this background, TSS or Tona Sintegra Solar have wonderful opportunities to gain the trust, the full trust of the investor to do excellent projects with rooftop, with big scale, from 1 megawatt, 6 megawatt, 7 megawatt peak for each project particular. And whereas we can apply, let's say, very advanced technologies like rapid shutdown to gain the most safety for the system, the zero export control to make sure that the system can comply with the governmental regulation to avoid any impact on the grid, or the hybrid controller where we can maximize or optimize the use of solar PVs for the system of the factory. So with these three factors, then help Tona Sintegra Solar really establish the full trust in building a reliable PV solar system for even very complex electrical system of the factories in Vietnam. And with that, I would like to see that the dedications, the passions to study new things, and the customer service mindset of Tona Sintegra Solar team has been the key factor for us to achieve this, I would say, proud achievement so far.
Thank you so much, ma'am. In fact, it's a proud achievement. It's a proud thing for us also to, facilitate you with the Grandmaster Award, because you are a very enterprising leader with 11 plus years of experience in international business management and entrepreneur. And you are an empoweress dedicated towards helping their customers in harnessing solar energy effectively and efficiently. Now that's a great lot contribution you have done to the solar industry. Thank you so much, and it's a pleasure having you.
Yeah, thank you
ma'am.
very much.
Thank you.
Thank you.
So we'll just move on to our next Grandmaster Award. The next Grandmaster Award goes to Gan Boon Hien, CEO, Leader Energy Private Limited. He is a pioneer with 30 plus years of experience in the power sector, contributing towards providing reliable, clean and affordable power with clean energy for the current and the future generation So stage is all yours, sir.
Thank you, Jita. Can you see me? Because I do not see myself in the screen.
Yeah, I can see you very well. I can see you. Thank you.
Thank you very much. Thank you. I'm in honor to receive this award. In fact, I'm a bit surprised to receive this. Leader Energy has been in the power industry for 20 years. We started as conventional thermal plants players, but we have since 5 years ago moved on to renewable energy. And we have taken definitely a policy, the company's policy that to move from now onwards, we only concentrate on renewable energy. And we want to grow more and more renewable energy, not only in the where I am now in Malaysia, but we are also very active in the region, into Cambodia, into Vietnam, and we are also looking into Thailand, Laos, and Myanmar as well. And again, thank you for the honor to be selected and then to be part of this solar community.
Thank you so much, Mr. Kan. Thank you so much for being a part of the award ceremony. Thank you. With this, we move to our next Grandmaster Award, and the award goes to And the next Grandmaster Award goes to Mr. Stephen Duthill, CTO, Sambior Solar. He is a leader with more than 18 years of experience in implementing telecommunication projects in the area of planning, commissioning, project management, and sales support. He has been working for the development of solar power plants in Asia and helping in reducing the carbon footprints. Can we have you on the stage, sir?
Definitely. Thank you very much. I can't switch on my video. I think it's blocked by the host.
Can we have that check, team, please?
Okay.
Yeah, we can see you now.
Yeah, thank you very much. I'm really honored to receive that award and humbly accept on behalf of the company and my team. We're really doing our best to spread solar technology all over Asia. And we simply stopped now selling solar PV plants. We're really trying to understand energy as a service to our client, helping them to reduce their carbon footprint and promote solar in the commercial industrial area. So once again, thank you very much.
Thank you. Thank you so much, Mr. Stephen. That was a short and sweet note from your end. Okay, so we'll move on to our last Grandmaster Award for the evening. Can we have our next award? So our next award goes to Jen Tan, Head Sustainable Solutions, Singapore, Semcom Industry. She is an experienced solar industry leader with a demonstrative history of working in the renewable sector. With good sales acumen and strong business development skills, she has contributed largely towards sustainable solutions for a brighter and cleaner tomorrow. Unfortunately, Ms. Tan could not be with us here today, but we have Mr. Tan Tek Hau to receive the award on behalf of her. So, Mr. Tan, can we have you on the stage, please?
Hi, can you hear me?
Yeah, we can.
Yeah, great. Hi, I'm Tek Hau. I'm receiving this award on behalf of Jen, and I'll be representing her to say a few words. So first of all, a big thank you to Solar Quarter for this award. She's honored to receive this title and would like to say that sustainability is everyone's responsibility, and we are simply fortunate to be making this our daily job. And Jen has brought Sembcorp Solar from a small outfit of 3 persons to a team of over 70 employees today, all in just over 3+ years. Sembcorp Solar is now Singapore's largest homegrown international renewable energy player, and we are definitely very proud of what Jen has done. Needless to say, she will not be resting on her laurels. She and the Sembcorp team will continue to work hard and contribute to the development of the solar industry in the ASEAN region in the foreseeable future. Last but not least, Jen wants to thank the Sembcorp team and all our partners for all the hard work and opportunities and support over the years. Thank you.
Thank you so much, Mr. Tan. That's a great speech from your end on behalf of our. So with this, ladies and gentlemen, we come to an end of our award ceremony, and a heartiest congratulations to all our winners. So with this, we'd like to end the award ceremony, and special thank you to all the participants for attending the show.